Okay, hey, this is another part of what you missed in live session 1, and this is talking about average rate of change. So you guys should have talked about average rate of change last year. It's one of our key features, and it's also something that's in your Florida Virtual School lesson for this week. Really important, average rate of change, or average rate of change, you'll see this a lot, is the slope of a line that connects any 2 points. So, if I had this, because this is a polynomial, it does not actually have slope, and that's because slope is a constant rate of change. Here we're talking about the average rate of change. So even here, if I was trying to do the ones that we have here, if this was x equals 1 and this is x equals 3, we would connect those 2 points, and we would find the slope of this line. Some things you need to know is that if your average rate of change is positive, then guess what? It's predominantly increasing. Or we could say on average, because it's the average rate of change. Which means that if your average rate of change is negative, on average, it is decreasing. So if we're talking about is the slope of a line that connects two things, then we need to remind ourselves what our slope formula is. Remember, m represents slope, which is our delta y over delta x. If you haven't seen delta y and delta x yet, that just means change. Anytime you see delta, it means change. So you may have seen it as y2 over minus y1 over x2 minus x1. And the big thing here is always remember that your y's go on top. That is why sometimes you guys hear it as rise over run, because your rise is your y's, your runs are your x's. And so just to remind you which one goes on top. So this is the information that we will need. But we are actually doing this in context of our problem. And so if we look at our problem, it says that we're going to need, find the average rate of change of the volume of the box on the last slide. So the last slide was talking about this one that was 10 feet and 17 feet. We created that equation. And so it wants us to find the average rate of change when x equals 1 and x equals 3. That means we need to know this full coordinate point. I'm going to show you how to find those coordinate points on Desmos. So we're going to switch over to Desmos. So here then on Desmos, we've seen this. We saw our graph, this perfect shape. We even came in and looked. We already talked about the maximum point, what that means for our graph. But now in order to find the average rate of change, I need these specific points. And so this is really cool. If you hit the gear, so once again, I'm over here where the equation is. You hit the gear. There's edits. There's something that looks like a table. Well, bam. I can actually put in what values I want. So negative 2 is highlighted. We knew that we needed x equals 1. Oops, sorry. And when I put in 1, I get 120. So I'm going to come back over here and say, okay, 1 was 120. And then we also needed 3. When I put in 3, I got 132. So that's what I'm going to use here. Now that I have these, I can go ahead and find my average rate of change. So I'm going to call this point 1 and this one point 2. That is important that you're doing them in the right order. And so my y is going to be 132 minus 120 over 1 minus 3. So we can go ahead and quickly do that math. 132 minus 120 is going to be 12. And then, oops, I even made a mistake here. So I can show you exactly the mistake I made. My coordinate point was 120, and my other coordinate point was 132 and 3. Many people make this mistake, but see how I had to crisscross each other to get those? That's how I know I set this up incorrectly. It should be 132, oops. Your coordinate points should always be on top of each other. So now if we do that again, you can see that I have a coordinate point right on top of each other and another coordinate point right on top of each other. We're going to just act like I did that correctly. And so this is what I mean by making sure you have it set up correctly. Your coordinate points always need to stack. So 3, 132, 3, 132, 1, 120, 1, 120. So 130 minus 120 was 12. We did that. 3 minus 1 is 2, which equals 6. So my average rate of change is 6. You would want to kind of put in your units there, but because the units here are kind of weird, kind of long, we're going to leave it as that. We will say that it's positive. So in general, as x got larger from 1 to 3, the volume increased. So once again, that's average rate of change. You're just taking the slope of the line that connects the 2 points.